Use the substitution u squared equals x minus 1 to find the integral of x squared over the square root of x minus 1, giving my answer in terms of x. So first thing, when I do integration by substitution, I want to replace the dx. So I want to differentiate my original substitution. Now, you might be tempted to say that u equals the square root of x minus 1 and to differentiate like that. And it will work, but I don't want to do that. I don't like differentiating with square roots. I think that makes it quite awkward. So instead of making u the subject at the beginning, I'm going to make x the subject at the beginning. So I'm going to say that x is equal to u squared plus 1. And then I'm going to differentiate that. And make dx the subject. So I can replace the dx with 2u du. Right, what else can we replace? Well, we've got the x squared here. And I know that x is u squared plus 1. So this is my x squared. X squared, this is the same thing as this. That needs to be divided by the square root of x minus 1. The square root of x minus 1, if we go back to our substitution, if I square root both sides, I find that u is equal to the square root of x minus 1. So therefore I can replace the denominator here with a u. Now replacing the dx with the 2u du. Right, we are now completely in the u world. And straight away I notice that the u here is going to cancel with the u here. Right, let's now expand these brackets. So I've got u squared will be u to the power 4. U squared times 1 is u squared, and 2 of those. And the 1 squared is 1. So this is me just expanding this. But then all of that needs to be multiplied by the 2. So actually we're going to have a 2u to the power 4. We're going to have a 4 here. That's right over the top. That's a 4. And that's a 2 du. Integrating each one of these terms then. So we'll get a u to the power 5 divided by 5. A u cubed divided by 3. And a 2u. Not forgetting a plus c. Now, I'm going to do a little bit of simplification here at this stage, because I can see that I could factorise a u outside here. I've got a u here, a u within here, and a u within here. So I'm going to factorise a u outside. I can also see that I can simplify and get a common denominator inside these brackets. So I'm going to times the first term by 3 to get 15. I'm going to times this second term by 5 to get 15. And I'm going to times the third fraction by 15. So this is going to give me 6 over 15 u to the power 4 plus 20 over 15 u squared plus 30 over 15. I can then take that's 15 outside to leave me with just this. I can then go a one step further, I think I can take a 2 outside here. So let's do that. Right, that is as simple as I can write it in terms of u. I need to give my answer in terms of x though. So we need to substitute back. Now I do remember that u squared is equal to x minus 1. So therefore, that will allow me to replace this u squared here easily. This though, the u to the power 4, well, that's going to be equal to x minus 1 squared. And the u at the front here, well, that's just going to be the square root of x minus 1. We've got that. So let's substitute each of those in to get back to the x world. So 2 over 15. We've got the x minus 1 to the power of a half. That's replacing the u. We've got 3 lots of the x minus 1 squared, plus 10 lots of the x minus 1, plus 15, plus the c. And I'm just going to simplify that a little bit. It doesn't actually say how I need to leave my answer, but it's good practice to simplify this as much as possible. So let's expand those brackets. We'll get 3x squared minus 6x plus 3 plus 10x minus 10 plus 15. And finally, collecting those like terms together, 3x squared, we've got a plus 4x, and then we've got a plus 8. And I think that is probably as simple as we can leave it. So that is my final answer.